2021 question 7. The first of the long questions. We're given the tip of a pendulum of a grandfather clock swing starting in this position up to here. Goes 45 centimeters on the way back down. Goes 45 by 0.9. So we have a sequence here: 45, 45 by 0.9, 45 by 0.9 to the power of 2. So the length of the first swing is 45. The second one, calculator use, comes in at 81/2. Third one's given. The fourth one, 6561 over 200. Nice easy intro, just calculator use, and 5 decimalizes on the calculator, 29.5245. TN, they give you TN here, don't even have to work it out. TN 45 by 0.9 to the power of n minus 1. We're asked to find T25. T25 is just straight into your calculator. T25 is 45 by 0.9 to the power of 24. And on the calculator, that is coming in at 3.589, and just one decimal place here, so 3.6 centimeters is that one. Part 3, the total distance travelled, SN. Write down your formula: A by 1 minus r to the power of n over 1 minus r. So we just need A and r. A was given to us was 45, and the ratio was given to us was 0.9. So again, calculator use: 45 by 1 minus 0.9 to the power of 40 here. We're looking for S40. Swing 40 divided by 1 minus 0.9 is just 0.1. I'm typing this into our calculator. We are going to get 443.34, and that would be in centimeters. And we want to the nearest whole number. Always check what they're asking. Nearest whole number 443 cm for part 3. Swing P is the first one that has an arc length of less than 2, so they always bring in a log type question here. So 45 multiplied by 0.9 to the power of n minus 1 has to be less than 2. We can check our answer here by plugging in our answer back into the original. So if we divide by 45, 0.9 to the power of n minus 1 has to be less than 2 over 45. I'll just calculate this at the end. So getting the log of both sides, n minus 1 by the log of 0.9 has to be less than the log of 2 over 45. Dividing by the log of 0.9 is dividing by a number less than 1, so it's going to reverse the symbol here. So n minus 1 will have to be greater than the log of 2 over 45 divided by the log of 0.9. So using my calculator, n minus 1 will have to be greater than 29.55 is what my calculator is giving me. So n has to be greater than 30.55. So n is equal to 31. So if we try the two terms, we will get that that is the correct answer. If we put them back into our original, I'll let you try that on your own. Here we're told the length of the pendulum is 1 meter. So there's my 1 meter and there's my swing. So the length of the pendulum, I think we had centimeters in the last case. We had 45 centimeters was the first swing. So we'll do it in centimeters here. We have our angle. So if the length of the pendulum is 1 meter, show the angle theta of swing 1 is 26 degrees, correct to the nearest degree. Well, there's a couple of ways we can do this. We can use radians here, or theta is equal to the length of an arc. So that's 45 centimeters here. So our radius is 100. So 100 theta is equal to 45. So theta is equal to 45 over 100. Theta is equal to 0.45 radians. you could use the other formulas for degrees here. So what's 1 radian? 180 divided by pi is 1 radian. So we multiply that by 0.45. We get what theta is. And it's not giving me 26 degrees, it's giving me 25.7831. Correct to the nearest degree though, when we go back up, is 26 degrees. Now, we have a choice here. We can use the 26 degrees. That's why they're telling us hence here. So let's just use the 26 degrees going forward and keep it simple. Find the total accumulated angle that the pendulum swings through, the sum of all the angle it swings through until it stops swinging. Well, that's to infinity. That's the sum to infinity. And to the nearest degree. Well, sum to infinity is a over 1 minus r. That's the sum to infinity. So a in this case, if we take the 26 from above, the ratio is still 0.9. We're going to get 26 divided by 0.1, which is just 26 by 10, which is 260 degrees. The first time I did this question, I used this one here. The end answers end up pretty much the same, so you can follow through with either of these and you will be given full marks in the exam. Then we're asked hence again, hence or otherwise. Find the total distance traveled by the tip of the pendulum. So here's my pendulum, it's traveling that way, then it's going back. When it has moved through half the total accumulated angle. Well, the total accumulated angle we got was 260. We divide that by 2, it's going to be 130. So when has the pendulum swung through 130 degrees? So that's going to be my original 26 by my 1 minus 0.9 to the power of n divided by 0.1. This is Sn. When is that going to be equal to 130? So if we multiply, we're going to get 1 minus 0.9 to the power of n is equal to 13 by 0.1. Or 130 by 0.1 is 13 divided by 26. That works out evenly. That's 0.5. So we're going to get 0.9 to the power of n is equal to, swap them over, 0.5. So n by the log of 0.9 is equal to the log of 0.5. So n is equal to the log of 0.5 divided by the log of 0.9. So n is giving me 6.5788. So that's n, that's the value of n. And we want the total distance traveled by the tip. So this was dealing with the angle. The formula that we used for dealing with the tip was our original one, which was 45 by 1 minus 0.9 to the power of n over 1 minus 0.9. So if we put in s of 6.5788, we're going to get 45 by 1 minus 0.9 to the power of 6.5788 divided by 0.1. So that's going to give me 224.98. Very, very close. Maybe if I didn't round it off, it might have worked out to 225 exactly. They may have started with the answer here and worked backwards to get this question to work out exactly as 225 at the end to the nearest integer. So nice. Question 7.